Hi, I'm Junel Sanalpin and this is my course project in data communication and networking flow. The objective of this course project is to discuss the one concept, to discuss the network evolution, and to discuss the network troubleshooting. First is the one concepts. Wide area network, also known as WAN, is a telecommunication network that expands over a large geographic area. One is the technology that connects offices, data centers, cloud application, and cloud storage. One operates beyond the geographic scope of land, and it's owned by the service provider, and the organization must pay for the fee for the one service provider. The service provider provides means to interconnect remote sites to transport data, voice, and video. One services providers includes carriers such as telephone network, cable company, and satellite service. One is important for the individuals, businesses, companies, and organizations because for business, organizations use one to communicate and share data with their branch offices or regional office. Organizations use one to share their information, to sell their products, and to promote their products and also to distribute their products. Employees who work in remote sites also use one to communicate with their companies. And for individuals, consumers use one to use the internet to access their bank, store, and variety of providers of goods and services. For individuals, they use the internet to research and to communicate all over the world. And for students, they use the internet for educational purposes such as researching and online studies. There are different types of one topology. First is the point to point. It is employ a point-to-point circuit between two endpoints. Second is the hub and spoke. It is a single interface to the hub that can be shared by all spokes. Third is the full mesh topology. It consisting of the routers that connected across a one cloud. Last is the dual home network topology, whereby a network device is built with multiple network interfaces. Each interface or port is connected to the network, but only one connection is active at a time. The other connection is activated only if the primary connection fails. Dual home topology also provides redundancy. One in the OSI model, it operates in OSI layer 1, which is the physical layer, and OSI layer 2, which is the data link layer. Physical layer consists of electrical and mechanical and operational connection. Data link layer is the protocol layer that transfers data between nodes on a network segment across the physical layer. There are different technologies used, such as HDLC, PPP, frame relay, Internet ones, MPLS, BSAT, and broadband. One standards are defined and managed by recognized institutions. They are the ISO, or the International Organization for Standardization, the IEEE, or the Institute of Electrical and Electronic Engineers, TIA, and EIA. TIA stands for Telecommunication Industry Associations, and EIA stands for Electronic Industry Alliance. There are common one terminology used. First is the CPE, or the Customer Premises Equipment. It is consists of devices and inside wiring located at the enterprise edge. Second is the DCE, or the Data Communication Equipment, and also name it it is also named as a data circuit terminating equipment. It consists of devices that pull the data on the local loop. The DCE provides an interface to connect the subscribers to a communication link on the one cloud. DTE, or the data terminal equipment. This is the customer device that passes data from customer network or host computer for transmission over the WAN. The DTE connects the local loop through the DCE. Demarcation point is the cable junction box located at the customer premises, and it is a point that separates the customer equipment from the service provider equipment. CO, or the central office, is the local service provider facility or building. Toll network, it consists of the long haul, all digital fiber optic communication lines, switches, router, and other equipment one provider network. Local loop, or the last mile, it is the copper or fiber cable that connects the CPE to the CO of the service provider. There are different types of WAN devices. First is the dial-up modem. A voice WAN modem converts the digital signals produced by a computer into voice frequencies. Access server. This server controls and coordinates the dial-up modem and may have a mixture of analog and digital interfaces. Broadband modem, a digital modem used with the high-speed DSL or the digital subscriber line, or it can be cable internet service. CSU and DSU are required by digital this line. CSU, or the channel service unit, it provides termination for digital signal. It has error correction and line monitoring. DSU, or the data service unit, it converts the line frames into frames that the LAN can interpret and vice versa. One switch, a multi-port internet working device used by a service provider. Router provides the internet working and one access interface ports. Core router and multi-layer switch. A router or multi-layer switch reside in the middle or backbone of the WAN. There are two types of WAN technology. One is the circuit switch. Circuit switch network is one that establishes a dedicated circuit or channel between nodes and terminals before the user may communicate. Second is the packet switch. In contrast to circuit switch, packet switching splits traffic data into packets that are routed over a shared network. Two kinds of circuit switch. PSTN, or the public switch telephone network, is the aggregate of the telephone networks operated national and regional. Second is ISDN, or the Integrated Service Digital Network, is a set of communication standard for simultaneous digital transmission of voice, video, data, and other network services over the digitalized circuit of the public switch telephone network. Two approaches of packet switch link. First is the connectionless system. Each switch must evaluate the address to determine where to send the packets, and each packet must have the full addressing information. Connection-oriented system. Each packet takes the same route through the network. Thus, all packets usually arrive at the destination in the order were sent. The network predetermines the route for a packet, and each packet only has to carry an identifier. Service provided networks are complex. They consist mostly of the high bandwidth fiber optic media using either SONET, the synchronous optical networking, or the SDH, or the synchronous digital hierarchy standards. SONIC is American-based ANSI standard, and SDH is a European-based HCM ITU standard. The DWDM, or the Dense Wavelength Division Multiplexer, is a newer public optic media development for long-range communication. One link connection option. There are two ways that enterprises can get WAN access. First is the private WAN infrastructure. Service provider may offer dedicated point-to-point baseline, circuit switch links, and packet switch links. Public WAN infrastructure. Service provider may offer broadband internet access using DSL, cable, and satellite access. Kinds of private WAN connection. First is the lease line. It refers to the organization paying a monthly lease fee to the service provider. These lines are called by different names such as lease circuit, serial link, serial line, point-to-point link, and T1 over E1 or T3 over E3 lines. In North America, service provider use the T-carrier system to determine the digital transmission, and in Europe, the service provider use the e-carrier system to determine the digital transmission. T1 supports the 1.544 Mbps and E1 supports 2.048 Mbps. For T3, it supports 43.7 Mbps and E3 it supports 34.368 Mbps. Second is dial-up access may be required when no other one technology is available. It is suitable when intermittent or low volume data transfer are needed. ISDN is a circuit switch technology that enables the local loop of PSTN to carry digital signal and changes the internal connection of PSTN from carrying the analog signal to the time division multiplex. ISDN also may require a terminal adapter. Terminal adapter is a device used to connect the ISDN basic rate interface connection to the adapter. Third is the frame relay. It's a layer 2 non-broadcast multi-access or the NBMA. A WAN technology is a packet switching telecommunication service designed for cost-efficient data transmission for intermittent traffic between local area networks and between endpoints in wide area networks. Frame relay puts the data in a variable size unit called a frame and creates a permanent virtual circuit, which are identified by data link connection identifier. That means that customers is a continuous dedicated connection without paying for a full-time lease line. Fourth is ATM or the asynchronous transfer mode. It is a technology that capable of transferring voice, video, and data through private and also to public networks. It also built on a cell-based architecture and supports the needs of T1 and E1, and ATN offers both PBC and SBC, allows multi-BC on a single leased line connection to the network edge. ATM also need almost 20% greater bandwidth than their frame relay. Multiple protocol level switching, also known or the MPLS, is a multi-protocol high-performance WAN technology that directs the data from one router to the next. It can carry payload including the IP version 4, the IP version 6, Internet, ATM, DSL, and frame relay traffic. WIS-AT or the Very Small Aperture Terminal is a solution that creates a private line using satellite communication. It is a small satellite dish similar to those used for home internet and TV. BSAT creates a private one by providing connectivity to remote locations. Different kinds of public WAN connection. First is the DSL, also known as the digital subscriber line. It's a model that uses existing telephone lines to transport high bandwidth data such as multimedia and video to service subscribers. Cable modem provides an always-on connection and simple installation. A device that connects a computer system to the internet via the cable television network and cable internet technology. There is the wireless technology, uses the unlicensed radio spectrum to send and receive data. There are different wireless technology. First, the municipal Wi-Fi. It is a municipal wireless network that provides a high-speed internet service for free, or sometimes it is payable, but it's less than the price of other broadband services. Next is the WiMAX, or the worldwide interoperability for microwave access. It provides a high-speed broadband service with wireless access and provide broad coverage like cell phones. Satellite internet. Satellite internet access refers to the internet access provided through satellites. Cellular service is another wireless one technology, and cellular technology is devices that use radio antenna, and the service provider has a larger antenna setting at the top of the tower. 3G, 4G wireless. It is abbreviation for third generation and fourth generation cellular access. LTE, or the long-term evolution, it refers to the newer and faster technology, and is considered a fourth generation technology. VPN stands for Virtual Private Network, a service that protects your internet connection and privacy online. VPNs create an encrypted tunnel for your data, protect your online identity by hiding your IP address, and allow you to use public Wi-Fi hotspots safely. A virtual private networks add security and anon- anonymity to users when they connect to the web-based services and sites. The Internet of Things, or IoT, is a phrase that denotes the billions of electronic devices that are now able to connect to our data, network, and the Internet. Describe the network of physical objects that are embedded with sensors, software, and other technologies to connect and exchange data with other devices and systems over the Internet. These are the examples of IoT versus the mobile phones, computers, peripherals such as um, mouse, keyboard, printer, webcam, headsets. Next, laptops, tablets, IoT smart home devices or IoT's home appliances. There are several smart home devices or home appliances that are now can connect to the internet. CCTV, bank ATM, medical equipment or medical devices. There are several medical equipment or medical devices that can also now connect to the internet. Sixth pillar of Cisco IoT system versus the network connectivity. Regardless of network type, they all need devices to provide network connectivity. Fog computing, this IoT network model identifies a distributed computing infrastructure closer to the network edge. It enables edge devices to run the application locally and make an immediate decision. It enhances resiliency by allowing the IoT devices to operate when connections are lost. It also enhances the security by keeping the sensitive data from being transported. Security pillar. The Cisco IoT security pillar offers scalable cybersecurity solution. Next is the data analytics. The IoT connects billions of devices capable of creating exabyte of the data every day. Management and automation pillar. The IoT greatly expand the size and diversity of the network to include billions of the smart objects, sensors, monitor, control, and react. Application enablement platform pillar. It provides the infrastructure for application hosting and application mobility between cloud and cloud computing. Cloud computing and virtualization, enabling individuals and organizations to store and access large amounts of data without worrying about the physical components. Virtualization is the foundation of cloud computing. Virtualization separates the OS from the hardware. The use of virtualization normally includes redundancy. Server virtualization is the process of dividing a physical server into multiple unique and isolated virtual servers. Using the software application, it takes advantage of add resources, and consolidated the number of required servers and server virtualization hides the server resources. Hypervisor, also known as the Virtual Machine Monitor, or VMM, is a software that creates and runs virtual machines, and is a program, firmware, or hardware that adds an abstraction layer to the real physical layer. The abstraction layer creates a virtual machine that accesses all the physical machine hardware. See, these are the CPU, memory, disk controller, and IC. The advantages of virtualization: it is less equipment is required, less energy is consumed, less space is required, it easier prototyping, faster server provisioning, it increased server uptime, improved disaster recovery, and legacy support. There are different cloud services: software as service, or SaaS. It is responsible for the access of the services. Platform as a service, or PaaS. It is responsible for the development of tools and services to deliver applications. Infrastructure as a service, IaaS. It is responsible for the access to the network equipment, virtualized networking services, and supporting network infrastructure. ITaaS. It extends the capability of IT without requiring investment in a new infrastructure, training new personnel, or licensing new software. Their different cloud model versus the public clouds. It is a cloud-based application and services over in the public cloud, and public cloud are made available to general population. Next is the private cloud. It is a cloud-based application and services offered in the private cloud are intended for specific organizations and entities, such as government. Third is hybrid clouds. Hybrid clouds are made up of two or more clouds. Fourth is community clouds. A cloud is created for exclusive use by a specific community. Cloud computing and data center. Data center are typically a data storage and processing facility. And cloud computing, it involves a large numbers of computers connected through a network that can be physically located, with its pay-as-you-go model. Abstraction layers. Computer system consists of abstraction layer. These are services, OS, firmware, and hardware. The advantage of the Type 2 hypervisor is management console software is not required. Type 2 hypervisor is very popular with consumers and organizations experimenting with virtualization and are free. The common types of hypervisor includes Virtual PC, VMware Workstation, Oracle VM VirtualBox, VMware Fusion, Mac OS X Parallels. Type 1 hypervisor is also called the bare metal approach because the hypervisor is installed directly on the hardware. Type 1 hypervisors are usually used on enterprise servers and data centers. Software-defined networking is redefining how the network administrator think about the architecture of their networks. Software-defined networking is an approach to networking that uses software-based controllers or application programmer interfaces to communicate with underlying hardware infrastructure and direct traffic on a network, and is an approach to network management that enables dynamic, programmatically efficient network configuration to improve network performance and monitoring. The network device contains a control plane and data plane. Control plane is the brains of the device. Data plane, also called the forwarding plane, typically the switch fabric connecting the various network ports on a device. Cisco Express Forwarding, or CF, is advanced Layer 3 IP switching technology that enables packets to forward at the data plane without consulting the control plane. To virtualize the network, the control plane function is removed from each device and performed by a centralized controller. The centralized controller communicates control plane function to each device so the device can now focus on providing data. Two major architecture. First is the software-defined networking. It's a network architecture that virtualizes the network. The second is the application centric infrastructure, or the ACI, a purpose-built hardware solution for integrating cloud computing and data center management. Other network virtualization technology are OpenFlow. It's a communication protocol that gives access to the providing plane of the network switch or router over the network and allows a server to tell network switches where to send packets. This was developed at Stanford University to manage traffic between router, switches, wireless access point, and a controller. Next is the OpenStack. This approach is the virtualization and orchestration platform to build scalable cloud environments and provide infrastructure as a service, or IaaS. The other components are I2RS, or Interface to the Routing System. TRIL stands for Transparent Interconnection of IoTs, of lots of links. FP, or the Cisco Fabric Path. IAE 802.18q, and shortest path bridging. Software-defined network is a network architecture that has been developed to virtualize the network. SDNR controller is a logical entity that enables network user to manage and dictate how the data plane of virtual switches and routers should handle network traffic. This is an application of software-defined networking architecture that manages flow control for improved network management and application performance. SDN, the SDN orchestrates, meditates, and facilitates communication between application and network elements. Application Programming Interface, or API. Northbound API, or Northbound API communicate with upstream application, and southbound API. It defines the behavior of downstream virtual switches and routers. OpenFlow are original and widely implemented southbound. North-south, it is going between external data center user and data center server, and east-west, going between data center servers. ACI, a data center architecture developed by NCM and acquired by Cisco in 2013. Cisco ACI is purpose-built hardware solution for integrating cloud computing and data center management. Cisco ACI Application Center Infrastructure is a software-defined networking solution designed to help organizations to manage complex environments by delivering network automation, increasing operation efficiency. Three core components of ACI: ANF, or Application Network Profile, is a collection of endpoints group, or APG, their connection, and policy that define those connections. APIC, or the Application Policy Infrastructure Controller. The APIC is the brains of the ACI architecture. Third is the Cisco Nexus 9000 series switches. These switches provide an application over switching fabric and work with an APIC to manage the virtual and physical network infrastructure. Spiny topology is composed of the APIC and Cisco Nexus 9000 series switches using two-tier spine leaf topology. The leaf switches always attach to the spine, but they are never attached. For virtualization, ACI supports multiple vendor hypervisor environment that would connect to the leaf switches, including Microsoft Hyper slash SVMM and slash Azure Pack, Red Hat Enterprise Linux OS, KVM OBS slash OpenStack, VMware ESX slash VMCenter slash B Shield. SDN type. The Cisco Application Abstraction Controller. Enterprise Module API or APIC EM extends the CI is aimed at enterprise and campus deployments. Device-based CDN. In this SDN, the devices are programmable by application run on a device itself or server in the network. Controller-based SDN. This type of SDN uses a centralized controller that has knowledge of all devices in the network. The application can manage devices and manipulate traffic flows. Policy-based SDN. This type of SDN is like controller-based SDN, where the centralized controller has a view of all network devices and an additional policy layer that operates at a higher level of abstraction. Policy-based SDN is the most robust, providing simple mechanism to control and manage policies. API, API-CEM features are versus discovery functionality that is used to populate the controller's device and host inventory database. Device inventory collects detailed information from devices, such as device name, device status, MAC address, IP version 4, IP version 6 address, iOS, firmware, platform, uptime, and configuration. Host inventory collects detailed information from the host with a network attachment point. Topology supports a graphical view of the network or topology view. It automatically discovers and maps devices with detailed level. Policy the ability to view and control policy across the entire network. Policy analysis, inspection and analysis of network access control policy, and the ability to trace applications. APIC/EMACL analysis. One of the most important features of the APIC/EM controller is the ability to manage policies. It analyzes and path traces, provide tools to allow the administration to analyze and understand the ACL policies and configuration. ACL analysis. It enables ACL inspection and interrogation across the entire network, exposing any problems and conflicts. ACL path trace. This tool examines specific ACL on the path between two end nodes, displaying any potential issues. Troubleshooting versus documenting the network. Network configuration files. It is contain accurate, up-to-date records of hardware and software used in a network. And system configuration file. It focuses on hardware and software used in end system devices. Server, network management console, and user workstation. Network topology diagram. It keeps track of the location, function, and status of devices in the network. Physical topology, physical layout of devices connected to a network. Logical topology, it illustrates how devices are logically connected to the network. Baseline performance level. Network baseline, the baseline is used to establish normal network or system performance. Establishing a network performance base requires collecting performance data from ports and devices that are essential to network operation. Step to establish network baseline. First is determine what types of data to collect. Second, identify devices and ports of interest. Third is determine the baseline duration. Troubleshooting. There are three steps to troubleshooting. First is to gather symptoms. Gather hardware and software symptoms from suspect devices. Gathering and documenting symptoms from network and system and user. Also gathering facts and evidence to progressively eliminate possible causes and eventually identify the root cause of the issue. Second step is to isolate the problem. It's the process of eliminating variables until a single problem or set of related problems have been identified and is the process of finding the root cause of the problem. Third is implement corrective action. After identifying the cause of the problem, the network administrator works to correct the problem by implementing, testing, and documenting the possible solution. Then, if the corrective actions create another problem or do not fix the problem, the attempted solution is documented. The changes are removed, and the network administrator restarts again to step 1. Using layer model for troubleshooting, OSI reference model. Troubleshooting using the method of OSI model. First is the bottom up, second is top down, third is the divide and conquer. In bottom up, start with the physical components of the network and move up to the layers of OSI model unit until the cause of problem is identified. The most network problem reside at the lower level of physical problem. Another method is a top down. It is troubleshooting. The troubleshooting starts with the end user application and moves down through the layers of the OSI model until the cause of the problem has been identified. This approach is used for simpler problems or simpler problems. Another method is divide and conquer. Troubleshooting starts by collecting the user experiences of the problem, documents and symptoms, and then using that information make an informed guess which OSI layer to start to investigate. Another method is educated guess by networking administrator. It is guessing by symptoms of the problem. Seasoned network administrator rely on their extensive knowledge and experience. Another method is comparing working and non-working situation, spotting the significant differences including configuration, software version, and other device property. Another method is the substitution. It's a quick troubleshooting methodology involving swapping the problematic device with known and working one. Troubleshooting tools, software troubleshooting tools, network management system tools. It includes device level monitoring, configuration, and fault management tools. Network management and monitoring tools are software platforms that connect with network components and other IT systems to measure, analyze, and report on network topology performance and health. Knowledge bases. Online network device vendors' knowledge bases are combined with Internet search engines, which can gain a vast pool of experience-based information. Knowledge-based software, also commonly referred to as help center software. It's a tool that helps you to create, organize, and manage self-service content for an audience. Baselining tools, it helps with the common documentation tasks, help keep network software and hardware documentation up to date, and help to cost effectively measure baseline network bandwidth use. Another tool is protocol analyzer. It is useful to investigate packet content. A protocol analyzer decodes the various protocol layers in recorded frame and present this information in a relatively easy to use format. Hardware tools. First is the Network Analysis Module or NAM. It provides an embedded browser-based interface that generates traffic reports that consumes critical network resources. Next is the digital multimeters. It is a test tool used to measure two or more electrical values, such as principally voltage or volts, currents or amps, and resistance or ohms. Cable testers. This device used for testing various types of data communication cabling, used to detect broken wires, crossover wiring, shorted connections, and improperly paired wires. Next is the cable analyzers, are multifunctional devices that are used to test and certify copper and fiber cables for different services and standards. Next is the portable network analyzer. This is used for troubleshooting switch networks and VLANs. Last is the SESLAG. It's a simple protocol used by an IP device known as a SESLAG client to send text-based lag messages to another IP device known as SESLAG server. These lag messages contain information about the operation and status of devices, as well as any errors or issues that may have occurred. Format. Characteristic of layer. Physical layer, the layer with the physical tangible properties. These are wire, parts, and antenna. Common symptoms in the physical layer: performance lower than baseline, loss of connectivity, network bottlenecks or congestion, high CPU utilization rates, console error messages. The causes of problems are power-related, hardware faults, cabling faults, attenuation, noise, interface configuration errors, exceeding design limit, and CPU overload. Data link layer. The characteristics of this layer, the protocol layer in a program that handles the moving of data into and out of a physical layer in a network. The data link layer is layer 2 in OSI. Common symptoms in layer 2, non-functionality or connectivity at network layer or above. The network is operating below baseline performance level. Excessive broadcast. Most common layer 2 console message is line protocol down. Causes of these problems: encapsulation errors, address mapping errors, framing error, STP pair or loops. The characteristic of network layer: this layer is responsible for package provisioning, including routing through intermediate router. It's a layer 3 in OSI, the portion of online communication that allows for the communication for the connection and transfer of data packets between different devices or networks. The symptoms in network layer are network failure, suboptimal performance. Causes of this problem are general network issues, connectivity issues, routing table, neighbor issues, topology, database. The characteristic of transport layer: it provides communication between application processes running on different hosts within a layer architecture of protocols and other network components. Commonly, ACL misconfiguration are selection of traffic flow, order of ACL entries, implicit data any, deny any, address and IPv version for wildcard mask, selection of transport layer protocol, source and destination port, use the established keyword, uncommon protocols, common interoperability areas, boot and DHCP, DNS and WNS, SNMP, tunneling encryption protocols. Characteristic or application layer is used by end-user software such as web browser and email client. It provides protocols that allow the software to send and receive. An abstraction layer that specifies shared communication protocol and interface methods used by hosts in a communication network. Application layer protocol are SSH, Telnet, HTTP, FTP, TFTP, SMTP, SNMP, DNS, NFS. Application layer progress prevents services from being provided to application program. A problem at the application layer can result in unreachable or unusable resources when physical, data link, network, and transport layer are functional. Troubleshooting IP connectivity. First is to check physical connectivity, check the duplex mismatches, check data links and network addresses, verify the default gateway, verify the correct path, verify the transport layer, verify access control list, and verify the DNS.